This call is now being recorded.
Hello friends, welcome to today's lab session. So we have started with the HDL lab. The first session has been already done. Today we'll move ahead and start with your next session. So friends, in the first lab session, what all did we saw? We saw an introduction to your Xilinx software, how to start the Xilinx software, how to create a project, and how to write the code in Verilog using Verilog structure. And also we saw how to simulate that program. So these all things have been covered in your first session, right? So I had also given you an assignment that you should download the Xilinx software from the online, from your internet, and try to write the simple program which I had covered in the previous lab, and also try to simulate it using the inbuilt simulator, which is ISM simulator. So these all things have been already done in the previous lab. Today, moving ahead, we'll go ahead with the next session. In today's session, we'll try one new thing. We'll learn a new thing, which is nothing but how to write a test bench. So today we will learn how to write a test bench. And in our syllabus, we will be writing the test bench to check the output of our codes. Test bench is nothing but you can just, the name itself tells you, test bench. So test is used to check the output. How did we check the output in the first session? We checked it by using your simulator, that is graphical simulator. We used the technique called as force constant and force clock. But in our syllabus, in the new syllabus, they have introduced this new thing, that is to write the test bench instead of directly forcing the values. So in order to do that, what we'll be doing is we will be writing a test bench. We will be writing a code. Test bench is nothing but a simple code which is used to test your circuit. Whatever the code you have written, to test that, we will be using it. Okay. Xilinx software. So this is your Xilinx software, friends. I hope you have went through these things. You already know how this is done and all those things. So in this Xilinx software, whatever you are seeing right now, here, we had seen this part of the code. We had seen this part of the code, wherein what we have done here, friends, if you remember, we have written a AND gate. We have written an AND gate. That is, we have simulated an AND gate. We have written a code which would simulate a logical AND gate. Okay. Now, in this, after we are written only till here, if you remember what I am marking right now, we are written only this much. And then we went to this simulation window. We simulated this code using your graphical inbuilt ISIM simulator. Right? Now, but to moving ahead, what we'll be doing in today's lab, as I told you, we will be writing a test bench. So this is what is your test bench from here. Right? So as I told you, what is a test bench, friends? It is a code which is used to check your program. Like say, for example, what is the program here now? AND gate. That means what I need to do, I need to check the output of this AND gate. How do I check the output of this AND gate? By using the test bench. Okay, so let us begin. We'll try to see what is your test bench. And I hope in your theoretical classes, you already studied your behavioral structure, data flow structure, and your structurals. So these three things are important. I hope so that has been already done. And please go through those videos before going through the lab videos so that the logic becomes more clear. Okay, now moving ahead. So I hope the screen is visible. Yeah. So moving ahead. So what we'll be doing here now? We will be seeing this code. I'm trying to zoom it 1 second. Yeah. So I hope so it's more clear now. Yeah. So we have written a new module. So please make a note here, friends. This is my main program. Whatever you can see here, this is my main program. So here I have written till here, my main program is over. So this is my main program. And from here, we are writing my test bench. So this is my, whatever you can see here, this is nothing but your test bench. So this becomes your test bench. Okay, so how do you, the usual name which we give for your test bench is stimulus. The name of the module is stimulus. Okay, now major thing, friends, very important thing. You might have already studied your resistors and wires, right? So remember, friends, all the inputs of your main program are written as resistor. You can note here. What is my inputs here? If you note here, what are my inputs? AB. You can observe here, what are my inputs? AB. So how AB is written here now? In the form of the resistor. Okay. Next, whatever are my outputs? What is my output here, friends? We have only one output, which is Y. So whatever my outputs are there, that is written as YL. So remember, in this procedure remains almost same everywhere. Okay. Now, what did we do then now? We have written our inputs. These are my inputs. We have written our inputs in the form of what now? Resistor. And we have written our outputs in the form of wires. Right. Next thing. We'll move it with the next step, friends. This step. So here what we have done now, here we will be instantiating your main program. What is the main program we have now? The main module name, if you observe here, it is EX1. So here also what we have taken? Here also we have taken EX1. To this, we will be giving a name, which is E1. This could be a user-defined name. Any name could be given. And then inside the brackets, here you will be writing all the inputs and outputs. What are my inputs now? A and B are my inputs. What is my output? Y is my output. So these things are written inside your instantiation. Okay. Now, going ahead, as I told you, what did we do when we executed the first program? We simulated it by forcing the values by using your ISIM simulator. So here what we'll be doing, we will be again forcing the values. How do you force the values? That is what we'll be seeing in this section. Whatever you can see from here, what I marked right now, it is nothing but it is how to give the values. So if I want to give the values, first thing you need to do is you should use a keyword called as initial. So you'll use a keyword called as initial. Next, you will write begin, and then you will be giving your values which you want to give as inputs. Okay. So the first values you will be giving is A is equal to 0 and B is equal to 0. A is equal to 0 and B is equal to 0. Okay. Now, so these are my first values. Then you might already know that what is the meaning of this hash 10. You might have studied in your theory class. Hash 10 is nothing but it gives you the delay. So the amount of delay which you want between this input and this input is nothing but your hash 10. So my next inputs are what now? A is equal to 0 and B is equal to 1. Right? Then what is my third input? Again with a delay of 10 seconds or nanoseconds. So I hope you know this. This is my time scale, which would be either in the form of nanoseconds or in the form of picoseconds. You can also use it as microseconds or just seconds. Anything can be used, no problem. Okay. So right now it is taking it as nanoseconds. Okay. Finally, the last one, which is A is equal to 1 and B is equal to 1. Then we are using here $50. The meaning of hash 50. The hash 50 meaning is nothing but the last execution, the input value's last execution would execute for somewhere around 50 nanoseconds. That is the last output would run up till 50 nanoseconds and then it will finish. So if you want to finish it, we'll be using $finish. So I hope this is clear, friends, how to give the values. Remember, your values are given inside your initial block. So this is my initial block. Inside your initial block, you will be writing all your values. Now, next thing. So you are given all the inputs. Now we need to see the outputs, right? We are already given the inputs. Now, as I told you, test bench is nothing but it is just to check your inputs and outputs. Okay. Now, that means what we are doing now? your inputs are done. Next, we need to see the outputs. So once it takes the inputs, it will execute this code, whatever the code you have written here, which is y is equal to a and b. Next, it will try to plot these inputs to that logic and it will give you the output. So again, initial, this is to plot your outputs. After initial, remember always there will be begin and end. So dollar monitor is nothing but what should be displayed. Monitor is nothing but what should be displayed. This gives you the time frame. Then T stands for nothing but tab. We'll be leaving some space. Once you see the output, you will get to know what is this tab. Then A is equal to percentage B. B is nothing but binary. The meaning of here, the meaning of B, percentage B is nothing but it stands for the input value which you are taking is binary. So that means it could be anything else as well. I can even give it as a decimal. In that case, I will be using percentage D, which stands for it is a decimal. Okay, so that is what we have written here. A is your input, B is your input. Both are in the form of the binary, which is zeros and ones. Then the output expected is also in the form of the binary. That's why it is again y is equal to percentage B. Then we will be displaying all your A, B, and Y. And begin, finish your initial, and finally end the module. So this is how you will be writing your test bench. So this is a new thing which has been implemented in this this syllabus. Earlier we were not having this. Earlier we used to do simulation by how I showed you in the previous lab. Okay, so learn that as well as this, because sometimes you may go wrong in writing this test bench. That is a ready-made thing. Directly we'll go to simulation and you'll simulate it. Now, okay, friends. Now moving ahead, we will check upon how to simulate this. So if you want to simulate this, earlier you will be here in the initial implementation here. So after implementation, again you can do your check syntax. So it will ask, do you want to save? Just say yes. Okay, then you press the simulation. So you can see here the check syntax has been done. It's a green tick. You can, I told you this console window is very important if you have any errors. Next, you click on the simulation. So you have selected your stimulus. Please check here, friends. If you click this plus mark, you can find out your upper module as well, right? So that means this, when I execute the stimulus, it is executing the stimulus as well as your example one, both. Okay. So we'll select this, then we'll do behavioral check syntax. So behavioral check syntax is completed. If any errors are there, it would be displayed here in the console window. Next, we'll be pressing this, simulate behavioral model. Okay. Yeah. Okay. So the window has appeared. So once the window has appeared, you need to click on this default.wcfg, which is nothing but the waveform window. So click on this. So once you click on this, you can see some waves have come. Now, we have forced n number of values, but only one wave is visible. So what you need to do is you need to click on this, which is nothing but fit to screen. It will fit all the values to screen. So just click on this. Yeah, now you can see all our values have come. So you need to drag this yellow marker to see a particular value. Just click on this portion. If I want to see what is the answer here, click on this portion. So A and B, the value is 0. The output is 0. Next, 0, 0, 0, 1. That is A is 0, B is 1. Output is 0. Next, 1, 0. The output is 0. Finally, 1, 1. The output is 1. So you can observe your friends, the last output has run for 50 seconds. That is from here, from whatever say around 30 nanoseconds. You can see here, from 30 nanoseconds, just drag this, yeah, from 30 nanoseconds up till 30 plus 50. That's why it is up till 80. You can observe here. That's why we are written here what now? Hash 50. So finish after 50 nanoseconds. One more very important thing. Everywhere we are written hash 10. It means what now? Each value has run for 10 nanoseconds here, from 20 nanoseconds to 30 nanoseconds. So this the similarly everywhere. Okay, you can see here. Fine. So this is one thing, friends, and this is your console window. Please observe here in the console window. See here. If I give a tab and those n, you can see the here difference. After 0, you can see the gap here. Then the values have been printed. then why that \n, so that new line comes, 10, then some space, and then the values. So that is very important, so make it readable. So this is what you will be having. Okay, so I hope it is clear how to write the test bench. So please go through it very carefully, the program. If you have any doubts, you can just ask us. Please practice it. Labs are everything about practicing. Without practicing, you cannot get more clarity. So please practice it. And if you have any doubts, you can ask us. Okay. So thank you for watching. Again, I will meet you in the next lab, wherein I will be discussing your first experiment. I hope all of you have your syllabus copy. If it's not there, I will be circulating it through the WhatsApp groups. Okay. So thank you for watching. We'll again meet in the next lab session.